When we allow expansion and contraction to occur without any control, the result is bound to be distortion, caused by this tough-looking villain, Mr. Shrink himself. He thinks he's pretty powerful, but we can show that Shrink is all brawn and no brain. We know that on any welding operation, Shrink is always right on the job. Look at him pull, and look at the distortion. Now that the damage has been done, let's slice off a piece of the plate and examine a typical cross-section of the weld. The overwelding here is a waste of time and money, adds nothing to the strength and performance of the joint, and in this case, caused abnormal distortion. Let's find a rule we can apply in a situation of this kind. Rule number 1. To prevent distortion, reduce the effective shrinkage force. In other words, always use as little weld metal as possible and make better use of the weld metal you need. We can also reduce the effective shrinkage force through proper edge preparation. This amount of bevel would require more weld metal than necessary. To obtain proper fusion at the root of the weld, with a minimum of weld metal, the bevel should be 30 degrees. But proper fit-up is also important. So, space the plates 1/32 to 1/16 of an inch apart. You will then need only a minimum amount of weld metal to produce a strong joint. Using fewer passes is another way of controlling distortion. For example, on plates that are free to move, distortion in this direction is always a problem. In this case, if we use 1 or 2 passes with large electrodes, we will greatly reduce distortion. In welding any structure, it is always important to consider the neutral axis. With a conventional fillet, the weld is so far off the neutral axis that Shrink has plenty of leverage to pull the plates out of alignment. But use of the fleet fillet method places the weld close to the neutral axis, greatly reducing the leverage so that Shrink cannot pull the plates out of line.